Good morning, all of you. Let's start with sets, class 11 mathematics. But before we really begin into class 11 mathematics, let's just go through the some of the basics of mathematics. Okay, let's just go through some of the basics of mathematics, and that starts, of course, with the numbers, the number system. Now, all of you may have heard, and then we have gone through this particular number, which we usually say, we have come across this, real numbers. Real numbers. In class 9 also we have studied these real numbers. 10 also we have studied about these real numbers. Now 11 also, 12 also. So real numbers is really going to be now a part of our life as long as we like study mathematics, and we just go on and on and on. Now what exactly are real numbers that we would really say? Real numbers. What are real numbers? Like, what is the answer for that? Like, what are real numbers? Like, real numbers are like what? Real numbers are numbers which are real. That's all, isn't it? Numbers which are real, right? But yeah, just not joking around. But like, what are real numbers? So today we're just going to study about like the number system, what are actually real numbers, and then because this is one of the basic core concepts of mathematics. Because like, you want to study mathematics but you do not know about the number system, so that's really going to be odd and weird, isn't it? Like, you do not know what is your complete number system, and yet you want to study mathematics. So it's just like telling your parents that, okay, mom and dad, today I'm going to cook, don't worry, I'm going to cook. But like, you do not know cooking, so what are you really going to cook, isn't it? So we really need to know cooking, then we can cook. So we really need to know about the number system. Now if you think back right from our primary classes, the different kinds of numbers that we have studied, groups of numbers that we have studied. So let's like go back to memory lane and then bring back some of the number systems that we have studied, the number groups that we have studied. Like first, if you remember, I remember that like you must have studied like whole numbers. You remember that whole numbers? First is like we have studied about whole numbers, isn't it? We have studied about whole numbers. Then of course, I'll come back to this one by one. Then let's just first now like rewind those number systems, like whole numbers. Then of course like we have natural numbers. Then even numbers. Then odd numbers. Then of course we have prime numbers. We have composite. Then when we move slightly higher up the classes, then we have come across integers. Then after integers, we have come across rational numbers. These are recent number systems that we have studied, and irrational numbers. Irrational numbers. Now let's go back to this number system one by one, and let's see for ourselves what are these number systems. Now let's start with whole numbers. Now what were whole numbers? Whole numbers were like it starts from counting from 0, isn't it? 0, 1, 2, 3, and so on. Whole numbers means like the full numbers, like complete numbers, no whole numbers. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and it goes on and on and on. Natural numbers. The way I used to remember natural numbers would be like the counting numbers. We have another name for natural numbers. The natural numbers are also called as like counting numbers, isn't it? So we do not count 0, we count 1. We start counting from 1. So natural numbers are counting numbers. So almost similar to whole numbers, but most of the times like we confuse, we make a lot of confusion between whole numbers and natural numbers. So the best way to remember is like natural numbers, counting numbers. So that's going to be like from 1, 2, 3, and goes on and on. Now we have even numbers. Now even numbers are also just like natural numbers only, but even numbers are those numbers which are like multiples of 2. So like 2, 4, 6, 8, 10, and so on. These are not very difficult numbers to remember. Odd numbers. Odd numbers are numbers, again just the opposite, which are not multiples of 2. 1, 3, 5, 7, 9, 11, goes on and on. And then okay, prime numbers. What are prime numbers? Well, let's just brush through this quickly. So prime numbers are those numbers which have only two factors, that is the number itself and 1. So examples like, now what do you mean by factors, for example? Like factors, what do we mean by factors? For example, like if I ask you like, what are the factors of 4? So what are the factors of 4? So the factors of 4 are like 1, 2 and 4. What do we mean by that, factors? So by factors we mean like by what numbers can you divide 4? Or what are the multiples of, like by what numbers can you divide 4 so that the remainder turns out to be like completely 0, completely divisible. So I can divide by 1, 1 4s are 4, 2 2s are 4, 4 1s are 4. So these are called factors. Now for prime numbers, the concept is like prime numbers should be divisible only by two numbers, that is like by itself and 1. So keeping that in mind, some of the prime numbers are, we start with 2 and 3, 5, 7 and so on and on and on. So 2, it has only two factors, 1 and 2. 3, it has only two factors, 1 and 3. 5, 1 and 5. So all the prime numbers will have only two factors, itself and 1. Alright. Many students, sometimes what happens is like they confuse. What is a prime number? You start a prime number, it starts from, so most of the students will say 1. 1 is not a prime number, okay? Because 1, how many factors does it have? Just 1. 1 has only one factor. So it should have two factors. So like 2, 2, 1, no 3, 1, 3. So it should have two factors. So prime numbers are those numbers which have only two factors. Composite, just the opposite. Numbers which have more than two factors like 4, 6, 9 and so on. Out of these prime numbers, we will see that only 2 is the even prime number. Okay, so like the name, there are questions like name the even prime number. So like there's only one even prime number, that's 2. The rest of the prime numbers are all odd numbers. Got that? So that's done. Okay, let's go back to integers then. We're moving up slightly now, higher up the level. Integers. What are integers? Let me keep it very simple. Okay, in my own ways, we will see. Here in my mathematics class, I'm not going to talk of like complex, complex words or sentences and all. Like I'm not going to be keeping that standard and all, because I know that I'm teaching you, dear students. You have come here to learn, so there's no point of me showing my standard here, isn't it? So I'm not going to be talking of big things. I'm going to be talking of in very simple language, like layman's language. Okay, so sometimes my words may not be perfectly mathematically very well defined and correct, but as long as you understand the concept, that's my main motive. Okay, so sometimes I'm going to use certain odd examples. Integers. The best way to remember, I'm going to give you that only. Mathematics, please remember, we do not memorize, we do not mug up and all mathematics. Find out your own ways, find out your own ways to like remember, to recall in your own way, more innovative ways. That's how we can retain the memory, isn't it? Integers. Integers, the way I used to remember, it would be like integers are like natural numbers. Natural numbers. What were natural numbers? Natural numbers like 1, 2, 3, 4, 5, goes on. Right. Integers are natural numbers. Integers are natural numbers and their negatives. Natural numbers and their negatives. So, natural numbers, what were they? 1, 2, 3, and so on. And their negatives also. So, like -1, -2, -3, and on. Right. Including 0. Including 0. Alright. Including 0. So this group of numbers, integers, 1, 2, 3, 4, these are called positive integers. -1, -2, -3, these are called negative integers. What about 0? 0 is neither a positive integer nor a negative integer. 0 is an integer only. Okay, it's not classified as positive or negative. We would call it neutral. It wants to be in peace. So let it be in peace. Okay. Then, so that integer problem. So remember, like decimals, not integers, fractions, not integers, because 2 by 5 is not a natural number. Remember, no natural numbers, counting numbers, 1, 2, 3, 4, 5. So 2 by 5 is a fraction, not a natural number. So it's also not an integer. Integers means solid numbers. 1, 2, 3, 4, 5, 6, not liquid numbers. -1, -2, -3, -4, and so on. Only no decimals, no fractions. That is also done. Then comes the most interesting part. Rational and irrational numbers. I'm very sure most of us, we get confused with rational numbers and irrational numbers. Let's go to the definition part, no? The boring same old definition. Okay, what are rational numbers? Rational numbers are those numbers which can be written in the form of p by q. Okay. What are irrational numbers? Irrational numbers are those numbers which cannot be written in the form of p by q. Fine. Then, with that, some examples of rational numbers, p by q, which can be written in the form of p by q. 4 by 7, no? 0.1, like 0.1 I can write it as 1 by 10, isn't it? 0.1 I can write it as 1 by 10. I'll just rub this off for once. 4, like 7. 7 is also a rational number because 7 I can write it as 7 by 1. 0. 0 is also a rational number, I can write it as 0 by 1. No, I can just go on writing like that. Not a big issue. So any number that can be written in the form of p by q is a rational number. So what are irrational numbers? Numbers which cannot be written in the form of p by q are called irrational numbers. So now with that comes the interesting part, that is think. Think of some examples of some numbers which you cannot write in the form of p by q. I'm giving a very interesting challenge here. No, think of some numbers which cannot be written in the form of p by q. Think. I'm going to give you some time to think. That's how we study. So think. Sometimes some of the answers that students give, like it's like 1.1, sir. Okay, 1.1, but 1.1, I'll show you a magic. See, I've written in the form of p by q, so definitely it's not irrational. So many numbers, minus 2. Minus 2 is like minus 2 by 1, so that's also an rational number. So now what happens is, I think you understand the problem here, that like we cannot find any examples like of the form p by q. So we have another definition which clearly explains, which clearly differentiates rational and irrational numbers. Please remember, this is going to be a very key role, an important role, okay, this rational and irrational numbers for mathematics. There's another definition that is that differentiates clearly about rational and irrational numbers. That's with respect to decimal system. That is like, in terms of decimal system, rational numbers are represented with R only. Okay, let me just write down. Rational numbers are like terminating decimals. Rational numbers are like terminating decimals. Terminating decimals, for example, like 4.5. So 4.5 is a rational number, terminating decimal, because 4.5 I can write it as 45 by 10. So it's in the form of p by q again, isn't it? So done. If they are not terminating, then if they are non-terminating, then they should be, we call it recurring, or in a layman's language, as I say, I'll be just speaking in layman's language, only simple forms, or repeating decimals. They are supposed to be non-terminating or repeating decimals. Example, when you divide 10 by 3. So if you divide 10 by 3, I'll get like 3.3333. You go on dividing, you're just going to get that only. So we can write it as 3.3 bar. So that's like non-terminating, repeating decimal. Right. Then what are irrational numbers? Irrational numbers are those numbers which are non-terminating, and it should be non-repeating also. Non-terminating and non-repeating. Okay, sorry, you couldn't see that. So it should be non-terminating, just a moment, yeah, got that. Non-terminating and non-repeating. So then it differentiates rational and irrational numbers clearly. Okay, non-terminating and non-repeating examples. Non-terminating and non-repeating examples like 1.1212212121212. So it's like non-terminating and it's non-repeating. Non-repeating in the sense like the same set of numbers should not be repeated. Some of you must be thinking like, sir, you're talking of non-repeating numbers. I can see 2 is repeated so many times. I'm not talking of that. The same sequence, the same set of numbers should not be repeated. So like 2, 2, 2, 2, 2, 2, 2, 2, 2, 2. It goes on like that. The same set of numbers. I cannot write it as like, for example, 1.22. 1, 2, 1, 2, 1, 2, 1, 2. So in that case, so I can write 1.12 bar. So that this is like non-terminating, repeating decimal, so it becomes a rational number. Whereas this is non-terminating and the same set of numbers are also not repeated. These are then in that case irrational numbers. So this is the best explanation for rational and irrational numbers. Okay, so in our lower classes like class 9 and all, you must have come across find out two rational numbers between 4 and 5, or irrational numbers. Let's say two rational numbers. So the boring method that we generally do is, okay, I add 4 plus 5 divided by 2, 9 divided by 2, 4.5. And then if I say 2, so other one like 4.5 plus 4 divided by 2, so I am not interested in those kind of traditional methods. No, it's not needed though. Not needed. Because if the general concept with you, until unless of course the question says use the formula. No, but most of the times these days, this is a new generation, 21st century, we are not going to be sticking too much on the formulas also. No. Provided it's mathematically correct, of course. So if you really understand the concept between rational and irrational numbers, then like between 4 and 5, you can have many rational numbers. 4.1, 4.2, 4.3, 4.4, 4.5, 4.6, it goes on. You want more? Okay. 4.12, 4.13. No, terminating decimals. All terminating decimals are rational numbers. You want more? Alright. 4.223, 4.721. You want more? No, I'm not going to write anymore. Again, there are so many of you. Please excuse me for that. There are millions of numbers that you can just find between 4 and 5 also. Rational numbers. Alright. So that's why. As long as it is terminating, repeating, terminating. If it is not terminating, then it should be repeating. Let's talk of like, let me give you a like 4.10, 10, 10, 10. So this also lies between 4 and 5. This is also a rational number. We can go on for our whole life. It's never going to get over, even between 4 and 5 also. Okay, so these are so many rational numbers. Okay, you wanted irrational numbers? Okay, I'll give you irrational numbers like 4.12. 112, 1112, 113, no, 4.01, 001, 0001. Again, like this also I can have like more than millions of irrational numbers. So that means now you must be thinking, then in that case, class 9, so many formulas we use to find rational and irrational numbers. You do not need that. It's as simple as that. That's the concept, but that should be enough. Alright. Okay, so I believe that the concept between rational and irrational numbers is clear. Okay, now, retracing back, what were the numbers that we wrote? Whole numbers, natural, even, odd, prime, composite, and then like integers. Then integers, then rational, irrational. Of course, some more examples of irrational numbers are like, to be more clear, like square roots of non-perfect numbers. We call it surds. Square roots of radicals, non-perfect numbers, like square root of 3, square root of 5. I'm not going to go details about this rationally, but these are some more common examples. Square roots of non-perfect squares are automatically irrational numbers. And I think that's all that the number system that we've studied, isn't it, so far? No? Whole, natural, even, prime, odd, composite, integers, rational, irrational numbers. All these numbers that you've studied, they are all called real numbers. Simple as that. So most of you must have been thinking so far, like real numbers. What are real numbers? Okay, real numbers. So every time somebody asks you about real numbers, then you go back, okay, what was the definition of real numbers? Real numbers, they're not needed. These are real numbers. That means, so far, whatever number systems that you have come across were all real numbers. Most of them were all real numbers. Why is it important? Because there's another number system that will come in class 11 very soon. That's going to be like imaginary number system. Imaginary number system, where we talk of which will give rise to complex numbers, where we discuss about imaginary number called the iota. I'm going to discuss more about that when the time comes. Have patience when the time comes. But here today we are just going to be talking about real numbers. I just wanted to discuss about real numbers. So next time when you see real numbers, then immediately you should know, real numbers, I know many. Chalo, if you ask me any real number, I'll give you hundreds of real numbers. But I've seen in my experience, like when we ask generally students, like, give me some examples of real numbers, they stand up and then they start thinking so hard, they keep on thinking and thinking and thinking that they cannot find the real numbers from the whole number system. So next time when your teacher asks, okay, give me a real number, name anyone. He wants more, give them more numbers. So these are all called real numbers. Okay, so I hope you have liked this video that I've made on an introduction on the basic concepts of number system. It's just a rough video. If there are any mistakes, please do forgive me for that. So if you have liked this, please do subscribe to my channel, and then please help it share with most of your friends so that they can just really exactly know what are real numbers. So more videos will come very soon, so stay tuned and please do subscribe to this. Thank you.